Now let's talk about one weather hazard that I know more about than anyone alive. Fog. That's right, I'm a walking, talking expert on fog because, I've been told, I'm always walking around in one. Anyway, you folks who live near bodies of water are probably as familiar with fog as I am. Fog is clouds that form on the ground. As you already know, clouds or fog will form when the temperature and the dew point are equal. Now, what are some things that can cause fog? Well, one cause is cooling of the ground on clear nights with calm winds. This results in a temperature inversion. In a temperature inversion, the air at higher altitude is actually warmer than the air down below. Instead of the normal decrease in temperature with altitude, you have the opposite. You have warmer air above. So what kind of weather would you get with a low level or low altitude temperature inversion? If there's a fair amount of moisture in the air, a high relative humidity, what you should expect is a temperature inversion with poor visibility, fog, haze, or low clouds. Not the best VFR weather. But you'd also expect to have very smooth air because there's not much in the way of vertical air movement. So how does a ground or surface-based temperature inversion most frequently form? By terrestrial radiation on a clear, relatively still night. If it's a clear night, the clouds will not trap the heat given off by the Earth, and it will radiate off on into space. Now, as the ground cools off, it cools the air just above the ground to the dew point. And what happens then? Fog in the form of radiation or ground fog. You're most likely to encounter radiation or ground fog in warm, moist air. You need some moisture in the air with low, flat land areas on clear, calm nights. Calm nights, because if there were a wind, it would mix that air up and keep the air adjacent to the ground from getting cold enough for the moisture to condense and radiation fog to form. Another common type of fog is advection fog. Advection occurs when warm air flows over a cold surface and the cold surface cools the air to dew point. Advection fog typically forms in the winter in coastal areas because in the winter large bodies of water are normally quite a bit warmer than the land is. That relatively warmer air over the ocean is also loaded with moisture. So as it moves inland, the air is cooled by the colder land. The moisture in the air condenses and forms fog, advection fog. Now, advection fog can also form when warm air moves over snow-covered ground. Another type of fog is upslope fog. Upslope fog is what happens when air is forced to rise up a mountain slope. When it rises up a mountain slope, the air moves to an area of less pressure and it expands. And when air expands, what happens to the temperature? Well, it cools. And when it cools to the dew point, what happens to the moisture in it? It condenses and forms fog right where that air is rising. Thus, there are two types of fog that need a wind in order to form and to exist. They are advection fog and upslope fog because in both cases it's the movement of the wind either across the colder surface or up a slope that actually creates the fog. Finally, we come to steam fog. Steam fog is typically found in the polar regions when colder air from the land moves over relatively warmer water. The warmer water adds moisture to the air, and when the air gets saturated, fog will form, and that fog is called steam fog. You've seen smaller versions of the same thing over lakes in the wintertime. Now, you can find icing conditions in steam fog when the temperature is below freezing, as well as low-level turbulence. So that should give you all you need to know about fog. And may the only kind you find be like mine, the kind you walk around in, not the kind you fly into.